Hi, this video is for Pythagoras equation. This Pythagoras equation is for right angle triangle. This one side is the A, another side is the B, and the hypotenuse is the C. Then we can say the A square plus B square equals to C square. Now you see here, this is the A of this side and the B is the base and this C is the hypotenuse, and this C equals to root of A square plus B square, and we can easily apply by this method and we can easily find out the inclined plane. Now this is a wall and this is a ground and another wall inclined on this wall. So if we can easily find out the length of this wall if we know the height of this wall and the distance from this wall to this inclined wall, suppose x. By this way we can use or apply the Pythagoras equation. Now this Pythagoras equation actually comes from the name of the Pythagoras. This Pythagoras actually the British philosopher born in 569 BC in Samos in the country of Greece and died in 500 to 475 BC. This is the around the time he was died, and in the place of the Metapontum in Italy. Actually his contribution is he was a philosopher and development of mathematics, astronomy and the theory of music. Also he had established a school at Crotone in southern Italy around the time 530 BC. Now how he had proved the equation. So this is a right angle triangle and this angle is the right angle and this side is the A and this square area is the A square and another side is the B and this square area is the B square, and this is the hypotenuse and this length of this hypotenuse is the C and this area equals to C square, and this area we have to prove that this C square equals to A square plus B square. This suppose this length of the this side is the 3 and the length of this side is the 4 and this hypotenuse of this right angle triangle is the 5. Now this 3 square plus 4 square equals to 9 plus 16 equals to 25. So equals to 5 square. So easily prove this hypotenuse equals to 5. By another way we can prove again this 13 square equals to 12 square plus 5 square. So by this dimension we can make the right angle, which is the you can say 169, actually 169 equals to 144 plus 25. Okay, by this way also we can prove this equation. Come to the another method. This method is called the algebraic method. So there is a square and we make a square inside this square and this dimension is the and this point is coincide with the side of the square and this point is dimension is the A, and this is the B, and this dimension is the B, and this is the C, and again to this point this is the C. Also this is a side of this small square. Now if we find out this total area of this square, then we can easily prove the Pythagoras equation. This is a one triangle, this is a triangle 2, this is a triangle 3, this is a triangle 4. Now this triangle, the x, y and z, and this height of this triangle is equals to A, and the base of this triangle is equals to B. So we can easily find out the area of this triangle, half into A into B, and total number of triangle inside this big square equals to 4. So we multiply by this 4 equals to, we get 2AB. So total triangle taken the area of 2AB, and this inside this square, the area of this inside square equals to C into C equals to C square, and this total area of this big square by divided, we actually divided by this total square area by the 4 triangle and one small square of area. So this total area equals to C square plus 2AB, and this is number 1 equation. So another, this is the A, and this is also the B, and this is the A. This total side of this big square equals to A plus B. Then if we want to find out the area of this square, then again we have to multiply the A plus B. So equals to A plus B whole square equals to A square plus B square plus 2AB. This is the number 2 equation, and this 2 equation area is actually the same. So equation 1 equals to equation 2. So A square plus B square plus 2AB equals to 2AB plus C square. So we can cancel this 2AB and 2AB. So we can easily find out A square plus B square equals to C square. Now you see here, this is a triangle, and this is a right angle, and this is a hypotenuse, and this is a two side of this triangle. One is the A and is the B. So by this way we can easily prove the Pythagoras equation. By another method we can again prove the Pythagoras equation. So there is a triangle, and we draw a line, vertical line on this hypotenuse of this triangle, and this is a right angle triangle, and again this is a vertical line. So again this one is a right angle, and this point is the A, another point is the B of this triangle. So this is a ABC triangle, and this vertical line coincide with the hypotenuse is the point of the D. So we take a different triangle. Actually this triangle, number 2 triangle, is the similar of this triangle. Again this is also similar triangle, this 3. So this 2 triangle is the similar triangle, and this big triangle is the number 1 triangle. Now again we have to prove the similar criterion of the 1 with 3 and 1 with 2. So, we take the triangle of ABC and triangle of ABD. So, now you see here the angle of A and here the angle of A actually the same. Again the angle of ADB and the angle of ABC, these two angles are actually right angle or 90 degree. So that we can say this triangle of ABC and triangle of ABD is the similarity criterion. So again we can say by this proportional method the AD by AB equals to AB by AC. So we can again say the AD into AC equals to AB square. By similar way we can prove the triangle ABC and triangle BCD are similarity criterion. So again we can say CD by BC equals to BC by AC. So by this way CD multiplied by AC equals to BC square. So this is a number 1 equation and this is a number 2 equation. So if we add these two equations, we get AB square plus BC square equals to AD multiplied by AC plus CD multiplied by AC. So we get the AC common and the inside the bracket the AD plus DC. So AD plus DC actually this AC. Now we can say AB square plus BC square equals to AC square. Now A square plus B square equals to C square. So by this way again we can prove the Pythagoras equation.